In this lesson, we answer a practical antenna question that almost every beginner asks. Why are some antennas compact and easy to build, while low-frequency antennas quickly become physically huge? To answer that, we need a clean link between operating frequency, wavelength, and practical antenna size. This is where resonance and wavelength fractions start to become useful instead of mysterious. For this lesson, resonance only needs a simple meaning. It is the region where the structure responds strongly near the right operating condition. We are not doing a heavy derivation yet. We only need the idea that frequency and physical dimensions are not independent. Near the right region, the antenna behaves much more effectively than it does far away from it. Now connect frequency to wavelength. Higher frequency means shorter wavelength, and lower frequency means longer wavelength. That is the quiet reason antenna size changes so much from one system to another. Once the operating frequency is chosen, the wavelength picture already starts telling us what sizes are practical. This is why antenna engineers keep using labels like wavelength, half wavelength, and quarter wavelength. Those labels are not just names, they are shorthand for physical size relative to the operating wavelength. And the moment someone says quarter wavelength or half wavelength, the next question should be, at what frequency? Let us anchor the idea with one concrete example. Suppose the operating frequency is 3 GHz, written as 3 GHz. That gives a wavelength of about 10 centimeters. So half wavelength becomes 5 centimeters, and quarter wavelength becomes 2.5 centimeters. Now the size labels feel physical instead of abstract. At first glance, low frequency can sound attractive because some channels feel more forgiving there. But the wavelength grows as the frequency falls, and that means the practical antenna size grows too. So the engineering trade-off is not simply about signal behavior, it is also about whether the antenna can exist in a realistic physical size. Keep 4 links from this lesson. Frequency sets wavelength. Wavelength guides practical antenna size. Labels like half wavelength and quarter wavelength are size shortcuts, and if someone gives you a frequency, you can begin estimating a realistic antenna size instead of guessing.